All right, we're going to go ahead and look at both chemical and physical changes. In the lab manual, the first thing that it asks you to do is to define or come up with a working definition of both a physical change and a chemical change. So you want to first come up with your working definition, and you're going to use that as part of your justification as you go through the lab today. So if you look at your lab, the first demonstration that I'm going to show you is the aluminum can. So the aluminum can is a regular soda can. I'll show it to you in just a second. Inside the can, I put about 20 milliliters of water. I put it on a hot plate, and right now it's boiling just to the side, and I'll show you that in just a second. Now, that's not the change that I want to take a look at is the boiling of water. What I'm going to do is I'm going to take that can. It's very hot. I'm going to use the tongs, and I'm going to invert that can into our ice bath. So this is very, very cold, probably around 2 or 3 degrees in Celsius. So it's not 0 because otherwise it would be all frozen, but there is some ice at the very top, and our water down below here is very cold. So we have a very hot can, and I'm going to invert it into our beaker, our ice bath. Okay. Here's our can. Here's our ice bath. All right, so hopefully you can see that. That is a implosion. Again, so what I want you to do in your lab manual is go ahead and write down, was this a chemical change or a physical change? And then what's your justification? Why is this chemical, or why do you think that this implosion to our can was a physical change? So chemical change, or was it a physical change? Our second one that we're going to take a look at is with two different solutions. One is copper sulfate, and the other, this is copper sulfate here, it's a blue solution, and ammonia is the other one. I'm going to mix these two liquids together, and in order for you to see this more clearly, I'm going to show you the desktop. All right, so here we have our dish, and let's go ahead and kind of zoom in there. All right, so ammonia is a clear liquid. It's a household cleaner used to clean like toilets and floors and things like that. So let me go ahead and add the ammonia into our dish. And there it is. Again, you can see it is a cleaning solution. It is a clear solution. And then I'm going to take a pipette and transfer some of the blue solution, our copper sulfate solution, into here. And watch what happens. Kind of spread it around. Now, I know it's kind of hard to see exactly what's going on. Let's see if we can get a little closer. There we go, that's about as close as I can get. This liquid, these two liquids, the blue copper sulfate actually turned into an amorphous solid. This is now jelly. This is an amorphous solid. Again, amorphous solid is a solid that can change its shape. So it actually created a jelly solution. So again, go ahead and write down your justification for whether you think it's a physical change or a chemical change. Our next one is going to be the hydrochloric acid and magnesium. Hydrochloric acid is the same kind of acid that is in your stomach when you digest food. It is also a clear solution. And magnesium is a metal. And I have a small piece of magnesium right here. I can show it to you here. Very, very thin metal. It's kind of a dark gray in color. All right, so I'm going to go ahead and add the magnesium into the acid. As you can see, a very vigorous bubbling going on here. And hydrogen gas is actually being produced from this reaction. So go ahead and write down either chemical or physical. And write your justification as that continues to bubble. All right, our next one is going to be with this piece of paper right here, kind of like an orangey color paper. And I'm also going to take ammonia again. Remember the clear solution that we added with the copper sulfate? And I have that in a small pipette. You can kind of see that there. So I'm just going to kind of put it on my hand, and then I'm going to put it onto the paper. Okay, so I'm going to put this onto my hand first. Put it onto the paper, and you can see it dripping down. So is this a chemical change or a physical change to the paper itself? Go ahead and write down your answer and your justification, chemical change or physical change. All right, your next one, I know many of you have seen this before, but I took a bar of ivory soap. This is it right here. Right, that's the half of it. And the one thing about ivory soap is that it's the only soap that actually floats in water. And that is because when they make this, they infuse it with oxygen, right? So oxygen bubbles are in here, so it enables it to float. Like if you're taking a bath, you don't have to search down for it. I took the other half and I put it in the microwave for 30 seconds. And this is what it looks like now. Big blob. Again, here is the original. Here is the other half of the soap. Was this a chemical change or was that a physical change? Again, write down which one you think and the justification for it. Our next one is going to be using a snack bag. You can use any snack bag. This happens to be veggie straws, but it could be Doritos or Fritos, Cheetos, or any other O's that are out there. Each of these bags is made of two different things. Inside is aluminum foil or aluminum of sorts, and then the outside is your plastic, which you can obviously color, put all your graphics on, put all the chemicals that are in here, the nutritional label and things like that, and any other messages that they're trying to give to us about their product. I put this in the microwave for about 3 seconds, and this is your product. Okay, so original, 3 seconds in the microwave. Physical change or chemical change. So write that down in your lab and then tell me why. So your justification of that. Our next one is going to be with some starch water. Okay, I have my water here, and this is the spray starch. If you've ever done any ironing, that's what this is. So I'm just going to kind of spray a little bit in there. Let it mix up by itself. And hopefully you can kind of see that. And it's slowly starting to mix in there. And then I'm going to add some iodine to another beaker. This is a little small bottle of iodine. You can see it's a pretty deep color, pretty dark. However, it's actually not that dark. Let me kind of show you here. It's kind of an amber color. So what I'm going to do is I'm going to take my starch water solution and I'm going to pour it from this one into the one with the iodine. All right, here we go. And it gives me a very, very nice purple color. And if I was to pour it back, we can get back to our original starch water, kind of a cloudy color. Was this a chemical change? Was this a physical change? And your justification. Our next one, our flash paper. Looks like tissue paper, like tissues, right? It's a little different. We'll do this twice, so watch closely. See that again? Instant replay. Chemical change or physical change. Record down your response and your justification of why you put down physical or chemical change. Our last one is going to be a cup of water. Have my cup, have my beaker of water. Now, as we study liquids and properties of liquids, we know that liquids have a definite volume, right? And they have an indefinite shape. They'll take the shape of the container. So this container is a little bit different than the size of this container. But let's go ahead and pour this in to here. Ready? Watch very carefully. Pouring the water in. Very nice. So this beaker was originally filled with 300 milliliters of water, which means there's 300 milliliters of water in here. But the shape is slightly different. This is completely cylindrical, and this, as it goes down, tapers somewhat downward and in towards each other. However, that's not the change, right? There would be no change there, with the exception of the shape changes slightly. But if I was to take this water and turn it upside down, and it doesn't come out, what kind of change is that? Is that chemical change? Is that a physical change? More often, water can change state very easily from a solid to a liquid, from a liquid to a gas, from a gas to a solid. All these phase changes happen very readily with water. But what happens when that water actually changes into a solid, an amorphous solid, a very jiggly solid? Is that a chemical change or is that a physical change? And why? Go ahead and put your answer and your justification. For the lab today, had you do two things. So if you go to the next part of the lab in the lab manual, we're going to use our justifications to see if we can more accurately identify some other changes. So the next part, I have a piece of chalk. And if you were to describe this chalk, you might say that, well, it's white in color. This texture is very smooth. It is a cylinder. It's pretty lightweight. It's a solid, okay? You might have other ways to describe this piece of chalk. Go ahead and list those down in the lab manual. And I have a mortar and a pestle. You might have seen these things before. They're used to grind. So that's what I'm actually going to do. I'm going to go ahead and kind of break it apart for a second here and grind it down to a nice powder. All right. Let me change the camera angle so you can have a better view of this. It's hard to see, but there is our powdered chalk. Well, how has it changed? Well, definitely the size and shape have changed. It's still a solid, but it's an amorphous solid, right? Because it has the ability to change shape. It's powder. You see it all there. How else has it changed? Go ahead and write down your answers in your powdered column. Then go ahead and proceed with the questions. Is this a chemical change? Physical change? Why do you think it's one versus another? All right, our last one. We're going to take a look at a paperclip. There's our paperclip there. And we're going to take a look at adding it into a graduated cylinder, as you can see, of copper sulfate. So before we add it in our data table, in the 0 seconds column, you're going to want to describe this paperclip. Well, obviously it's irregularly shaped. I basically opened it up. It's rather bumpy or rough in certain areas. It's silver, right? It's a solid. Can you think of any others to add to that? So we're going to do this for 5 minutes in total. And so we're going to take our paperclip, we're going to add it to our copper sulfate solution, and once a minute we're going to make an observation of the paperclip that is in our solution. So we'll come back to this in 1 minute. As we're waiting over the course of this time, I want you to go back to your initial data table that we did our predictions for, or our observations for the demonstrations that I did. Are there any up there that you want to reconsider or rethink? Are there any parts of your definition from part 1 that you might want to start to change as your definition is starting to hopefully change a little bit into when you can accurately identify a physical change versus a chemical change? So we're coming up to about a minute. Let's go ahead and I'll show you, and I don't want to take it out of the cylinder, but I want to show you the cylinder, and hopefully you can see this. Look to where the paper clip is before it enters and where it is at the 1 minute mark, which we're just hitting now. Something that I automatically see is color change. Definitely changes color from the point that it enters the graduated cylinder. So definitely color. We'll wait about another 30 seconds before we make our second observation at minute 2. Physical changes. These are changes that definitely look different. Okay, thus the word physical. So it physically appears to be different. So is this experiment a physical change, or is it a chemical change? That's what we're trying to figure out. All right, let's go ahead and take a look at minute 2. Let me bring it up here close, so hopefully you can see. Again, something that I'm seeing, especially towards the bottom, is a little bit of bubbling. Some bubbles are beginning to form, especially towards the bottom area. And I will say, I know it might be hard for you to see, we definitely have a stronger color change in the paper clip. So that's at the 2 minute mark. Again, as I've been talking, time is ticking, so that's why I'm every 30 seconds I'll go ahead and take a look at it again. Physical changes, as I mentioned, are more appearance. So what's the difference between a physical and a chemical change? Well, chemical changes. A really good indicator of a chemical change is they're irreversible. I can't normally go back and get what I originally started with. That's another really good indicator of a chemical change. All right, let's go ahead and take a look and do another observation. See if you can see anything different happening. The reason why I'm getting really close, because just under where the 9 is at the paperclip, you might see stuff on the left and the right of the paperclip. It looks like stuff is growing or getting fuzzy on there. And that is actually happening. So a great indicator of chemical changes, as I mentioned already, there's another one. Something new is being produced. So number 1, irreversible. Number 2, if something is there that wasn't there before, another really good indicator of a chemical change. Whereas a physical change, nothing new shows up. It looks a little different. If I was to take a piece of paper or an index card, right, I tear it in half. Is it still paper? Is something new produced? Is it irreversible? Is it reversible? Well, I could do this, right? I could put it back together. I could maybe get a piece of tape, basically get it back to where it was. So physical changes, a little bit more of reversible. And there are irreversible physical changes, though. All right, let's come back to minute 4. See if we can see anything different. I mean, for me, I'm definitely seeing more of that fuzziness appearing along more of the paperclip. The other thing I'm actually noticing is that, and I know this is hard to see on the computer, is the solution is getting a little bit lighter in color. So not only to the paperclip, there's a small change, but there's also a change in the color of the copper sulfate solution. Now, color change is a fantastic indicator of a chemical change, but there's also obviously physical changes that are color changes. If I was to spray paint a wall, is it still a wall? Yeah, absolutely. If I was to take some food coloring and put it in water, is it still water? Absolutely. So those are physical changes. But when things change color without adding color, that's usually a good indicator of a chemical change. All right, our last measurement at approximately 5 minutes is going to be actually taking the paper clip out so we can see it a little bit more clearly. So I'm going to go ahead and do that. I'm going to try to do it slowly here so I don't mess anything up. All right, so here is the paper clip now at the 5 minute mark. And again, you can see the line, very distinct line where the paper clip was touching the copper sulfate and the fuzziness of your paper clip, what is now on there that wasn't there before. So again, I've already talked about what kind of changes those are. So for the questions, go ahead and answer the question about this portion of the lab, as well as the 2 analysis questions at the end of the lab. Of course, as always, if you have any questions, please feel free to email me and let me know.